we are now going to work on integration by parts. Now this video, however, will look at how the formula is derived and the preparation leading to answering many questions. But the first thing we need to ask ourselves is when to use parts. Well, integrating a question that involves a product of two independent expressions that involve x. Now the best way to explain this is with two examples I'm going to give you. First example, integration of x cos x with respect to x, and the second example being 5x squared ex, again with respect to x. So what do I mean by two independent expressions? Well, if you look at the first question, I can clearly separate x and cos x, and you can see I've got two expressions there, both involving x. Likewise, I can do the same for the second example, and I can separate it after the 5x squared. One being 5x squared, the other being ex. Now, before we start looking at the integration by parts formula, we need to look at the background, the behind the scenes. In other words, where did it come from? In order to do that, we need to look at the product rule. Product rule being part of differentiation, a branch of calculus. Now, you should know the product rule, and I'll just remind you the product rule being d dx of uv, in other words dy dx, is equal to u dv dx plus v du dx. Now if we look at that formula, what we need to do is rearrange that to make u dv dx the subject. And that's simply just by moving one expression. At the same time, we need to integrate with respect to x, and then we create the formula as you see. And that formula is the integration by parts formula. Quite complicated to look at, but we're going to make it easy. We're going to look at how we define each part. So, before we do that, we need to look at comparing product rule and integration by parts. Now, unlike the product rule, one of the independent expressions relates to u, whilst the other relates to dv dx. Now, in most cases, u relates to the xn expression, such as x squared or x cubed or 7x to the power 4. But exceptions will apply when involving expressions involving the natural log. Now, the idea behind integration by parts is the expression relating to u is differentiated to find du dx, whilst the expression involving dv dx is actually integrated to find x. And that's the important part. So let's look at a previous example. We're not going to quite do this example to the end. This video is all about preparing. But if we look at integration of x cos x dx, we can separate x and cos x, as we said before. Here, u would become x, and dv dx would become cos x. And in turn, we'll then have to differentiate u, in other words du dx, and we'll get an answer for that. And then for the second one, we'll have to integrate the cos x, and we'll get v. If you look at the second example, we had 5x squared ex dx with respect to x. We can clearly separate 5x squared and ex as two separate expressions, as we mentioned before. Here, u would become 5x squared, and dv dx would become e to the power x. And subsequently, we'll then need to differentiate u, in other words, differentiate 5x squared, and integrate to find v, and integration of ex. Now, today is not about actually working that out. Today is about planning it. In other words, preparing it, finding out what u is, finding out what dv dx is. Once you've established that, we can go on to the next videos and look at how we actually solve it. Hope you enjoyed it. Hope you took it all in. See you later.